Hello, everybody. Welcome to our presentation and to our user day, to the presentation DiagRA Embedded, our modular and platform-independent and highly integratable solution for diagnostic. My name is Andreas Hege. I've been working for DiagRA Consulting for almost 25 years. So my responsibilities are leading the operating business unit with a sub-business unit, automotive products and professional service. I'm one of the 3 general managers at DiagRA Consulting. So let's start with the agenda. I will show you the trends and the challenges in diagnostic. Things are changing right now. We are having some different issues for diagnostic that need some kind of different setups and some kind of different software architectures in the future. What is DiagRA Embedded? I will show you how to the ingredients that make up our product. We will face some very common things that we already know with diagnostic, like transport protocols, like diagnostic functionalities, like diagnostic protocols. That's all part of our DiagRA Embedded. We will have a case study. We'll have an application that is based on DiagRA Embedded. It's called a Flash Hub. And this is an application that makes you able to flash up to 10 ECUs in parallel with our software. Use cases and scenarios, I will show you where DiagRA Embedded can be applied and how we support our customers with projects, with products, with integrations and everything like that. And right at the end, we have some kind of summary that ends my presentation. Now let's start with the trends and challenges in diagnostic. First of all, I will show you the classic setup that's been around in diagnostic for almost 25 or 20 years, I say. So on the left-hand side, you have the vehicle. The communication interface is connected to that vehicle, and on the other hand, on the right hand side, we have the diagnostic tool, which is able to do OBD communication or workshop communication to set up the data and to connect to the vehicle on the left hand side. So by the way, what's the difference between measurement and diagnostic? So we also have some measurement tool that Hanuman showed you before. So the main difference is that measurement is like spying things or reading out some data that are already there. So just listen to the car for things that happen anyway in the car. So diagnostic is some kind of different. So commonly when you are doing diagnostics, you are having active requests to the vehicle or to the ECU, and also get some explicit response from the vehicle, either a one-time response or some kind of cyclic response from the vehicle. So what things are going to change in the near future? So I just showed you the setup, and on the other hand, I will show you now some social and cultural changes and trends, and also some changes we have in the automotive industry that might affect our way we are thinking diagnostic in the future. First of all, social and cultural changes. So right now we have cloud infrastructure and big data. Every one of us has a smartphone and is connected to the cloud almost from morning to the late night. So that's what we are expecting right now. So we started with some kind of floppy and some kind of printed out data and something like that. But in the future, we will store our diagnostic data right in the cloud, and where we have almost every time access to them. Next of all, we have smart hardware and IoT. You all know some kind of smart TVs or fitness tracker or something like that. Smart watches, what we already have. So this gives us a little hint where we go in also in diagnostics. So we have hardware, small hardware, and we are running some kind of diagnostic on it, and then we are controlling this smart hardware probably with our smartphones and our applications. We have mobile applications. Bring your own device, which means that our apps on our smartphone will control our diagnostic applications, and it's not just enough to have a computer and install some kind of software on it. You need admin rights, you have some virus scanner and everything like that. So what we are expecting is that we have mobile applications running on multiple devices like smartphones, and being able to access our diagnostic applications over these apps. We have cloud services and pay-per-use. So of course, you've got a couple of cloud services on your smartphone, like messenger services or streaming services like that, and that's what we probably also face in diagnostic. On the other hand, we have trends in industry and automotive. First of all, we have some kind of automated driving and connected vehicles. So it's not only the workshop that reads out our data in the future. It's also the vehicle that's right or left side from us, right in the middle of the traffic, which means that vehicles will communicate, they will share data, and this changes a lot when it comes to diagnostic. Industry 4.0 and predictive maintenance. So let me just explain what predictive maintenance is here. So it is some kind of an artificial intelligence that is able to predict when to exchange parts of our vehicles and everything like that, which means that the downtimes, for example, for heavy-duty vehicles will be able to minimize, so that you may recognize that your vehicle is going to break just before it's going to break. So this is predictive maintenance and diagnostic data. We need a lot of diagnostic data for learning the artificial intelligence algorithms to make this come to life. Telematics and remote diagnostics, that's what I said. We're not only going to the workshop and read out the data in the future. We have some scenarios where we read out diagnostics right during your drive, and also we have some scenarios where you're just standing on the bridge and trying to read out the vehicles that are passing by right beneath these bridges. High-performance computing and service-oriented diagnostic are some kind of trends that are more in-vehicle related, which means that high-performance computing in terms of automotive is that IT infrastructure will be installed in the vehicle in the future. and which means that the electrical engineering should be reduced a little bit. It's not more about bits and bytes and transport protocols and everything, but it's more like services that are provided by the vehicles to be able to gain high-level diagnostic functions. Automotive Ethernet and in-vehicle operations. So we have some buses or some communication transport in the near future, or even have it, and which means the diagnostic applications will not more run outside the vehicle, but will run inside the vehicle, and that's related to the services. If the diagnostic runs inside the vehicles, so the services are exposed outside the vehicle to be able to make diagnostics. And last but not least, we have sustainability and electrification, which gives us a lot application for diagnostic. So, for example, in battery management and so on. The other question is, what is DiagRA Embedded? So first of all, the DiagRA Embedded is a set of C++ components. So this is a user day and not some kind of a C++ hackathon. So when I will try to explain the components of our DiagRA Embedded software by using the well-known aspects of diagnostic, like transport protocols, like diagnostic protocols, like high-level diagnostic functionality, like flashing. So ingredients of our products are small and well-designed components, like a CAN library that connects us to the CAN bus, like J1939 library that is able to make SIE J9039 communication with heavy-duty trucks. We have another transport protocol like diagnostic over IP library, which connects us to Ethernet. We have a higher level UDS service lib, which makes us able to make UDS communication to the vehicle, like ODX supported and everything like that. We have a socket CAN library that supports a socket connection on Linux systems. We have OBD lib that exports the SAE J1979 communication, and some higher level functionality like flash station lib, which makes us able to do some flashing with our DiagRA Embedded. And we have a couple of more libraries that are connected to each other and are the base building blocks of our software. So what to do with these base building blocks when it comes to applications and everything. So let's have a look at what we are able to assemble for our customer. So when we are now looking at assemblies, that the real things that do diagnostic when we ship them to our customer and use them internally. So first of all, we have some applications. We have which means that we assemble our components, our libraries, and write some glue code and assemble them to applications. We add some user interface to them, and then we are so able just to do highly fit to our customers' needs. So I will show you the flash station in the next couple of slides. That is a good example for the applications we are assembled from our components. What else do we have? We have higher level components, which means we assemble our components together and make our customer able to integrate these components on a specific platform within their software, which means we are providing some kind of C++ libraries on a specific platform like Linux or like Raspberry Pi or something like that. And then we ship them to our customer, and our customers license these higher level components to use them and to integrate them in their own software. As a third part of our assemblies, I will show you some kind of decorated components. So not every customer has the use case to integrate C++ libraries in their own software. So what do we do in this case? We have our components, and what we are decorating them is that we are providing some kind of specific interfaces. I'm showing you here the REST API we are putting on top of our component, or we are doing some kind of a specific API or a web service interface. So these are typical interfaces we equip our components with, just to make them able to act like an application for our customer. Our customers are then able to integrate them with high-level programming languages like Python or in the server or something like that. So this is very integrative for our customer. So what are the platforms we are able to deploy our DiagRA Embedded? Well, first of all, we have the simple desktop platform. We are compiling our DiagRA Embedded for desktop as an application, have some kind of user interfaces, and can use them like our classic DiagRA D with some specific user interface. Then we are able to run DiagRA Embedded on a dongle, which means we have some kind of a smart device, like some kind of an IoT device that is connected to the vehicle and runs our DiagRA Embedded core software on it, and we are able to control this software on the dongle via an app on a mobile phone or something like that, which means we have no user interface here and have some services that are provided to control our software. We are selling our component to telematic providers, and which means that we have a component here, and the telematic use cases integrate our diagnostic software to acquire data and running them on a pre-installed telematic unit in the vehicles. And last but not least, but this is some kind of the things we will face in the future, is that our DiagRA Embedded runs right in the vehicle. We have some security and safety issues here, and these are not really solved right now, which means it will take, I think, a couple of months, a couple of years until our software is also able to run in the vehicle in a safe and secure environment. Let's now look at our Flash Hub. It is an application that is powered by DiagRA Embedded. So this is the user interface, and you see if you look on the right side, we have up to 10 ECUs that can be flashed in parallel. This is very efficient for our customer, just to connect to 10 ECUs that have the same file, that have the same manufacturer and the same type, and then press the button and start flashing all 10 ECUs. On the other hand, we are able to to set up 10 different ECUs. For example, you have one car and have 5 different ECUs and flash them in parallel. And we are using multiple interfaces with multiple CAN channels, which means they are really independent on the level of the transport protocol right now. Let's look at the features of this flash hub. We have, that's what I said, parallel flash programming of up to 10 control units. We are currently using 2 interfaces with 5 CAN channels each, which brings us to the 10 control units. We are able to either to flash 10 ECUs of the same type, or we are able to flash different control units with different flash files in parallel. We are supporting ODX files and S19, hex S19 files right now. As you've seen, we have user experience driven design, which means that we are able to provide our customer exactly what they need and support them when it comes to an efficient process and efficient working flash process when they are using our tools. And it currently runs on Windows and Linux. We are mainly selling this application on Windows right now with a classic setup, as I said, with 2 interfaces, 5 CAN channels, which is 5 CAN channels each on Windows. So next, let's go to the use cases and the scenarios. We have identified for DiagRA Embedded. So first of all, we have some kind of the classic setup with a simple back-end integration. So that's what I said in my introduction with the trends and challenges. That now we have some kind of a vehicle. We have acquired, for example, OBD data and have the classic scan tool that is connected to the vehicle and gathers this OBD data, but we are not saving these kinds of data in some kind of files, but we forward them to a backend where they are stored and where they can be analyzed and where we have pay-per-use and everything like that. So Peter Stoß will show you a little bit more about this kind of use case. Next, we have this proximity mobile diagnostics setup. We have an advanced client handling. We have still the vehicle, of course, but now we have not an interface, we have a dongle. And this makes us able to be more flexible with our user interface, which means our core components with the diagnostic functionality are running on the dongle as an IoT device or a smart device, and as you are controlling your TV or your smart app via your smartphone, you will be able to control diagnostic that runs on the dongle with some application that's also running on your smartphone. And your smartphone is very good in connecting to the internet. You're using messenger services and so on. So that is something your smartphone is really good at, which means that taking the data from the dongle and forwarding to the back end is a very smooth and straightforward process that can also be secured by encryption and everything like that. So smartphones and backends are very good in doing that, and so they are connecting to some smart hardware. So the next use case, we are looking at our telematic use cases where we have a telematic unit that is built into a vehicle and runs when the vehicle has some specific state, for example, has some temperature or is started, or the key is turned and everything like that, which means that here we have some kind of jobs that are forwarded from an IoT backend. They are loaded. They are downloaded to the telematic unit, and the jobs are run when the preconditions are fulfilled. Which means that what I said, for example, if you have some kind of a specific temperature, the job starts running, and the job's results are then asynchronously forwarded back to the IoT backend. And the jobs and the job results can be then analyzed with mobiles or terminals, or they can even create it with mobiles and terminals. So this is a typical use case where, for example, also IoT protocols are involved, like MQTT, where you have jobs created with your iPhone, forward them to your IoT backend, then deliver them to your telematic units, and then after a while you get the results from your telematic unit. So last but not least, the in-vehicle use case where you have the diagnostic is running itself in the vehicle. So the vehicle provides the services that are then can be controlled via, for example, an IoT backend, or directly with a mobile or a terminal. And then so probably I think we will go through an IoT backend in the future, but the IoT is not just a dongle or telematic unit. So the IoT device is your car, like you have your smart TV or something like that. So the technical side is I mean, it's very smart, and it's okay just to do that. But on the other hand, it has some specific and severe consequences for safety and security. I mean, we are not faced here with a smart TV. We are faced with a vehicle that can kill people. So we have to ensure that everything is secure and safe in this kind of use case. So how we support you with our product, we come right to the point where we write and involve you as our customers. So what we can do for you is we can act as a product partner. So we are crafting applications like the Flash Hub that you've seen, and we can provide a fast time to market on proven components, which means we have the basic diagnostic functionality. We assemble them together and make your branded application, and can deliver the diagnostic functionality very quickly. We are acting as a component vendor. So that's what I've shown you before. We are having specific components for different platforms, for Linux, for Windows, for different processors, which can be delivered to our customers and supported and maintained, and are used to be integrated in our customers' applications. We can tailor our existing products, which means we have, for example, like the Flash Hub, we can make over the branding, we can customize some kind of functionality, and in this way we can develop high customized products on the base of our components. As a solution provider, so we can plan and ship and host telematics solutions for our industry partners, which means we are hosting backends, we are planning some kind of security and safety functionality for your solution, and just solve the problems for you with some setup that we are setting up for you. And as a product partner, so you can hire our engineers and which support you by planning, implementing, and even doing services for you that are DiagRA Embedded related. So let me come to my summary right now. So how can a DiagRA Embedded benefit for you, our customers, in the future? So as you've seen, we have various platforms, we have various use cases that we are supporting, and we are sure that our software will suit your platform and your use cases. So come to us, see us, and tell us your use cases, and I'm sure we will find a solution based on DiagRA Embedded when it comes to diagnostic functionality. We are connecting diagnostic know-how with smart software design. That's what I've shown you, that we are well-cutted. We are based on well-cutted components that makes you able to define exactly what you need and what you don't need. And that lets you select exactly from our building blocks, which means, for example, if you need diagnostic over IP, and that's perfectly okay. We have the right tool for that. If you need UDS instead of OBD, you get just the software with one module instead of the other, which means we're highly integratable with our modules at this point. We have other benefits, of course. We have a C++ library, which makes us able to assemble applications with a very small memory footprint. We are highly performant on small systems. And of course, when you buy some solutions or even some components, these components are proven by many setups and customers, which means you are not some kind like a beta tester on our diagnostic software, but you are really benefit from others that have already bought our system and integrated them. The components are easy to integrate either as C++ libraries. However you say that's easy, but anyway, so we are also able to assemble applications around our components, and also to equip our components with specific interfaces like web service interface or REST API, which makes you able to do diagnostic on a very high level. Yeah, that's from me. I will thank you. And now we have a 10-minute break, and after this break we have Peter Stoß with his DiagRA D and Silver Scan Tool presentation. Thank you, and have fun during the last presentation.